In recent years, the continuous emergence of new multimedia services represented by augmented reality and virtual reality has brought new challenges to the fifth generation of mobile communication networks. At present, XR content is mainly local content playback or wired content transmission, which limits the application scenarios of VIA to some extent. At present, XR video transmission can only meet the basic XR experience of users, and there is still a huge gap between the industry application needs for a high-quality XR experience anytime and anywhere. Solving the real-time wireless transmission of XR content is the key to meeting XR mobility. Scientists who are from WIMI Hologram Academy of WIMI Hologram Cloud Inc. discussed how to use the 5G network to help the development of XR with the continuous popularization and application of the 5G network. The following is the integrated view of science and technology of WIMI Hologram Academy, which has cutting-edge guiding significance for 5G network helps XR-D2D based XR content transmission. Wireless virtual reality, hybrid reality, and augmented reality are very special applications, but also have extremely high requirements for large bandwidth, ultra-reliable, and low latency requirements. Data is sent to the user terminal at gigabits per second under the constraints of low latency. Therefore, wireless XR connectivity requires an intelligent network designed to meet reliable, low latency, and seamless support for different network scenarios. The demand for the high bandwidth of XR undoubtedly brings great pressure to the limited spectrum resources. As one of the key candidates for 5G, D2D is an important issue worth exploring and studying to use D2D's technical advantages to facilitate XR content transmission. Device to device, also known as the terminal pass-through. D2D communication technology refers to a direct communication mode between two equivalent user nodes in a decentralized network composed of D2D communication users. Each user node can send and receive signals and has the function of automatic routing. Network participants share a portion of their hardware resources, including information processing, storage, and network connectivity. These shared resources provide services and resources to the network and can be directly accessed by other users without going through intermediary entities. In the D2D communication network, the user node plays the role of both server and client, and the user is aware of each other's existence and self-organize a virtual or actual group. D2D users can directly transmit data, avoid cellular wireless communication, do not occupy the frequency band resources, and greatly improve the utilization of the spectrum. Resource sharing among adjacent users can provide a better user experience. Improving the efficiency of XR video transmission and ensuring the efficiency of user scope may be a feasible solution in future XR application scenarios. According to the characteristics of high bandwidth, low latency, and high reliability of XR, a D2D-based XR content transmission mechanism in the 5G scenario are proposed, specifically as follows. Content server. An MEC server is mainly used for XR content storage and transcoding. The MEC server can, through intelligent autonomous cache, XR users can cache to the edge computing server in advance and transcoding, make the appropriate content closer to the user, reduce the delay of the XR content preparation. XR user devices transmit XR content data through the 5G module. Meanwhile, with the D2D module, XR users can transmit XR content to nearby XR users or receive XR content transmitted by nearby XR users. The D2D-based XR content transmission in the 5G scenario needs to consider the application characteristics of XR and the complexity of the transmission mechanism, which needs in-depth research and exploration. This paper mainly describes two main aspects: applicable scene and main challenges. Through the D2D communication function, data transmission between adjacent users such as XR content sharing and interactive games can be conducted. XR users can find interested XR users in adjacent areas through the discovery function of D2D. With the growing multimedia business with large traffic characteristics such as XR brings great challenges to the core layer and spectrum resources of the network. The local multimedia service conducted by using the local characteristics of D2D communication can greatly save the resources of the network core layer and spectrum. The cellular communication between close XR users can be switched to D2D communication mode to realize the unloading of cellular network traffic. Of course, the multipath transmission of XR content can be performed by combining D2D with the cellular network. The application of D2D technology in the 5G communication network can effectively solve the problem of insufficient spectrum resources and greatly improve the utilization rate of spectrum resources. However, The sharing of spectrum resources may interfere with the user's communication, thus affecting the user's communication experience. XR users can receive XR content data from other users through one-hop or multi-hop D2D communication. However, XR is sensitive to the delay. How to select appropriate relay users while ensuring the delay is a comprehensive optimization problem. Close XR users found that it is the key to XR content transmission based on D2D, especially in the interactive XR scene. How choosing users with the same interests or hobbies is the key to meeting the delay requirements of XR content for D2D transmission. Close XR users found that it is the key to XR content transmission based on D2D, especially in the interactive XR scene. How choosing users with the same interests or hobbies is the key to meeting the delay requirements of XR content for D2D transmission. Because of the characteristics of the high bandwidth, low latency, and high reliability of XR, we propose a D2D-based XR content transmission mechanism in the 5G scenario, which caches some XR content to the edge in advance with the help of MEC, based on D2D communication. An XR user can transmit XR content to a nearby XR user or receive XR content transmitted by a nearby XR user. In short, improving the efficiency of XR video transmission with D2D communication and ensuring the co of users is a feasible solution in future XR application scene.